Testing. Okay, that's loud. Nice. Thank you for having me. Weights and Biases. Thank you everyone for joining. Really excited to be here. My name's Harrison. Chase. I'm a CEO and co-founder at LangChain. LangChain's developer tooling for building LLM applications. So we have a bunch of abstractions and chains and make it really easy to get started. And when I was thinking about what to speak about today, there's a lot in LangChain, and so it was a bit hard to choose. But I think the thing that's most interesting to me at the moment, and I think the most unexplored in the ecosystem, is generally memory, the concept of memory for LLM applications. So that's what I'll be talking about today. It's going to be a bit of an unsatisfying talk because I have more questions than answers, really, and I'm not really trying to sell anything. I think my goal here is to introduce a bit of the problem, talk about how we've been thinking about it at LangChain, talk about the Generative Agents paper, which was an amazing paper that came out about a month or so ago out of Stanford, and I think is the most interesting paper in the memory space, and then just leave you with some closing thoughts. And I think this is a space where we'll see a lot more attention in the next few months, and so I'm really excited to have the chance to just talk about it and nerd out about it with you guys today. So the general problem is that LLM APIs are stateless. When you pass a call to OpenAI at the moment, and then you pass another one, it doesn't remember what came before. On the other hand, a lot of the applications that we build are not. So I think looking at examples of this, chatbots is an immediate example. You want the chatbot to remember what came before in the conversation. More complex forms of chatbots can include things like personal tutors. We did a webinar on LangChain and education last week, and I think a lot of the things that people were building were personalized tutors, which I think is an amazing application of this generative technology. And I added this third one in here. I always get asked, what's your favorite application that you see being built on LangChain? And I think one of the most creative ones is a dungeon master to play Dungeons and Dragons. And I think, one hand, I like that because it's really creative. The other reason I like it is I think it's an amazing example of why memory, and memory is a broad term, and I'll talk about a bit more specifics later, but why memory in general is really important for a lot of these new applications. As a dungeon master, you have a lot going on that you need to remember and come back to and make sure is internally consistent. And so I think it's a fun application of that. The memory modules we have in LangChain are mostly aimed at conversation. I think that's the place where memory is most readily obvious. If you're having a conversation, the thing that you're chatting with better remember what you said before. It's been around for a while. I mean, I think chatbots jumped to everyone's mind when generative AI came out, and so we've supported this for a while. The other thing I'll say, though, is memory doesn't just apply to conversation. At the end of the day, when I talk about memory in LLM applications, what I really mean is remembering previous interactions and then using those to inform future interactions. And so I think that can come into play in other settings besides chatbots. A obvious example being if you've got an agent that's doing a task, if it remembers how the task went before, what adjustments you wanted to make to the course that it took. Remembering these things can help guide it, and this ties in nicely to the concept of reflection, which I'll talk about in a bit. But I just want to highlight that although a lot of the modules we have in LangChain are really focused on conversation, that's not the only application where memory is important. So I'll skim quickly through some of the memory modules that we have in LangChain to kind of talk about how we currently think about it and how we have been thinking about it. So probably the simplest form of memory is what we call conversation buffer memory, and this basically just keeps around a buffer of the previous memory or the previous chats and passes them back into the language model so that it has as context what was said previously. There's different ways to select the number of messages that you pass back in. Obviously, the more you include, the more context it has. At the same time, it's more costly. And at some point, you'll run past the context window length. It's pretty simple. It's pretty easy to understand. You can kind of see what's going in, see what's coming out. The cons are, you currently can't pass in everything, and even if you could, that's not incredibly efficient for making a lot of generalizations. The next kind of version of memory that we have is what we call conversation summary memory, and this just basically keeps a rolling summary of the conversation. So every interaction, it will update the summary and then pass that back in. Again, the pros of this are it's pretty simple, it's easy to understand, you can easily introspect and see what's going on. It's also reasonably configurable. So right now, we run it every chat message, but you could imagine a scenario where you run it every 2 or 3 or 5 or K chat messages and then update the summary accordingly. The cons, again, are it loses some of the detailed information. So you have a summary, you don't have the exact specifics of the messages, and it's really mostly only relevant in conversation settings. A simple kind of like combination of these two is also really efficient. So you get the best of both in some sense. You get the specificity of the previous messages, and then you get a summary of the longer conversational context before, and so we support that as well. These are some of the more basic types of memory that we have in LangChain. The next two that we have are a bit more advanced, a bit more complicated, and touch on this concept of reflection and updating some sort of state. So the first that we have is conversation entity memory. And what this does is it extracts knowledge about specific entities and then updates a knowledge store of those entities. This was added by Sam Whitmore, who was an early contributor to LangChain and an amazing follow on Twitter. And so the generalization of this is the state that's being kept is this entity store, the mapping from an entity name to some information about that entity. And then basically, after a conversation, you can update that by essentially asking the language model, what do we now know about person X? And then adding that in to the description of person X that we have in the knowledge base. And then the way that gets used in the prompt is when you're chatting with this system, before the language model responds, it will parse out who the entities are, look them up in the knowledge base, and then pass that in as context. So the state here is basically this mapping of entity to entity summary. A slightly broader generalization of that is the idea of using a knowledge graph to represent various things. And so again, there's this concept of you've got this state. In this case, the state is a full-fledged knowledge graph. And you update the state every turn. So you extract new knowledge triplets every turn and then insert them into the knowledge graph. And then again, you use this state in the conversation by querying the knowledge graph for relevant triplets. And that's a bit context specific, but the idea is, again, there's this generalization of you've got this state, you're updating it again, here it's every conversation, but you can imagine that being every 5 messages, every 10 messages, kind of at some cadence. And then there's this way of incorporating the state back in. It's just this state is taking different forms. That's what we've got in LangChain. We've also recently added some stuff from this Generative Agents paper, which is an amazing paper that came out of Stanford. It's got a lot of really cool things in it. I think the 2 main things that it has that are interesting, one is it has a simulation aspect. So if you haven't read this paper, what it does is it creates 25 different agents and puts them in a simulation, a Sims-like simulation, where they're going about their day. There's this complex setup of the code for the simulation has not been released. We did not try to replicate that. That would have been way too intense for us. But it's this really intense setup where you've got 25 individual agents, all with their own memory and agenda, and they're interacting in this environment. So the simulation is one of the parts of this paper. But the part of this paper that I'm more interested in is the memory that they use for these agents. So they constructed a type of memory that depended really heavily on reflection. And so reflection can take a bunch of different forms, and arguably some of the things I mentioned earlier around entity memory, knowledge graph memory, summary memory, all of these involve reflection. They involve reflecting on the previous messages and then updating some state. And so this paper did that as well. They did it in a few different ways. First, they reflected on the importance of a memory. And so when observation happened, they gave it a score of how important it was. And this was used later on when retrieving from the database and putting it back into context. And so that was the first form of reflection they did. Another form of reflection they did, which was, I think, even more interesting, is they added, so that you have these concepts of observations, and those form individual memories. They then inserted like another type of memory, which wasn't a specific observation, but was basically generalizations of many observations. So after n observations that asked the language model to come up with a list of questions that you could ask based on those observations, basically a list of insights that you could gather, then for each insight, they'd go over that, they'd create that insight, and then they'd insert that back into the database. So you're now augmenting your database with a bunch of these reflections. The reason I think this is so interesting, and I'll talk about this in the next section around retrieval, now when you retrieve memories, you're not retrieving specific observations, but you're retrieving these reflections, which carry higher order meaning and higher order, basically synthesize a lot of individual things into one specific sentence or however it's represented. And I think that's really powerful because one, it allows for a bit more efficient retrieval. You can just retrieve this one thing instead of 100 things. But then also you're explicitly taking this time to reflect on those observations. So a lot of the progress in language models and getting them to do things in a reliable way has come from this idea of like asking the language model to think step by step, show its work. There's this concept of basically asking the language model to slow down. And I think this concept is reflection is similar in a sense where you're explicitly giving in this case, a system, you're giving the system a chance to reflect on what those observations mean, rather than just stuffing those observations into the prompt and asking it to generate an answer with keeping these observations in mind or something like that. So that covers the reflection. Now how they did retrieval I think is really interesting. It's kind of like a three-pronged attack where they weight more recent memories higher, which makes sense if it just happened. It's very similar to human memory in some sense. If it just happened, it's more present in your mind. They weight it by importance. Again, very similar to human memory. I remember my birthday better than I remember like a random breakfast I had a few years ago. And then they've got relevancy weighted. And so this is just looking up based on semantic similarity or something like that. So they remember similar events. And they combine all these things. And importantly, they're not just doing this on the individual observations. They're also doing this on the reflections that they made. And so through this process, they're retrieving these observations, and then they're inserting it into the prompt and asking the agents to continue their simulation with those things in mind. And so that's an overview of the current state of LangChain and probably the most interesting paper that I've seen. We have an implementation for that in LangChain as well that a lot of people have played around with. But I think it's more interesting to think about what's not in LangChain, because I think there's a lot of potential for these educational bots to have a more complex form of memory, or for these chatbots to have a more complex form of memory. And I don't think we're really seeing that in the moment. And I think that's something that's a little bit hard for us to think about how to do, because I think this idea of memory can often be really context specific. I think there is this generalization where there should be some reflection step that looks at some observation and updates some state accordingly. And then I think there should be some step that fetches from that state and puts it into the prompt. But that's like, what I just said is incredibly like vague and abstract. Like state could mean anything. And I think that's where the application specific stuff comes into play. That's where I think, depending on the application you're building, you might want to consider a few different options. And that's also something I'm extremely excited about. As I said, it's tough for us to do because we're more of a horizontal kind of like infra tooling company. But we'd be extremely interested in working closely with people that do have those types of applications, because I think this is an area that's incredibly underexplored. And so whether we have the chance to work together or not, my closing thoughts on this is it really comes down to two things. Like, what is the type of data that should be in memory? What does this state look like? And that probably will be context specific and application specific. And then how can you use that memory in generation? And so just to touch on the different types of memory that I think you should be considering. And a lot of these come from the Generative Agents paper. You've got this recency bit. I think that's important. You do need to remember the previous things that just happened. Those are likely always going to want to be in memory. You're going to want to remember the relevant things. You're going to want to remember the important things. And I've bolded reflection here because I think this is the new thing that language models really enable. I guess language models enable, in some sense, enable relevancy because that's mostly done through semantic search. In some sense, they enable importance because, at least in the Generative Agents paper, you're using a language model to score that. But I think this concept of reflection is really the new bit, and that's what I'm really excited to explore more. And then the last bit is just how do you use this during the generation. And so I think the common things are, you've got previous messages, you can just put them in a buffer, you can put them in a prompt. You've got related events that you pull in through a vector store, you can also put those in as these are related things that happened previously. But the last thing, and this is probably the most important things in terms of really unlocking this, is how do you use the state? How do you take the state that you've reflected on, you've updated, whatever form it may be, and how do you put that into the prompts? And I think there's a bunch of different examples of that. I think it's really context specific. And I'm really excited to see what everyone builds in this vein, because I think this is an underexplored but incredibly exciting avenue for large language models. That's all I have for today. Thank you guys for listening. Thank you, Weights and Bias.